will be a very impactful section. Thank you so much. Good evening. I see you fit from now. Today we'll be having collaborating with three chapters: Now University of Nigeria, Bayero University Kano, and University of Port Harcourt student chapter. Thank you so much. We already have on the call the person of Mr. Dolapo Odeni, who will be the person taking the opening remark. It's a pleasure to have you here, sir, and for joining us this early. Good evening, sir. Okay, you're welcome. Purity.
Hi, Juliana. Good evening.
Good evening, sir. Thank you so much for joining in.
You're welcome. Good
Um,
evening, everyone.
okay. We also have on the call Melissa. She's the SP president of NA University. Thank you so much for joining in. Please kindly share to your network. We'll be starting anytime soon. Anytime soon, just in a few minutes. We just want more people to join in. Due to some technical issues, our moderator has not been able to join on the call, but we'll still be kicking off anytime soon. Thank you. All right. I've just been informed by a reliable source that our esteemed speaker is here with us on the call. Is the YP from the session, Worry session, the person of William Okon. You are welcome, sir. Please, if you're on the call, you can just say hi to us.
Yeah, good evening, everyone. Thank you very much, Ms. Juliana.
All right. Thank you so much, sir. Thank you. It's a pleasure to even have you here so early with us on the call. Thank you. I see you, Anthony Eze. Welcome. You joined in as the first person on this call today. I would want to also thank you, Mr. Amos. He's a content development lead in ALP in the session. Thank you so much for being here with us. Okay. I'd like to confirm, um, is Chizobam on the call? Chizobam Chris Chikwe. Are you on the call yet? Okay. Think would be starting. Let's just give few more minutes for more people to join in, and we'll be starting shortly. All right, if you're excited to be in the session, I just want to see your emojis on the chat box to know if tell us. I want you to tell us where you're joining us from. Today we have three sessions joining us. If you're on the chat box, please just tell us where you're joining us from. Is it SPA, Nile, Bio, BUK, or University of Port Harcourt? Please kindly signify in the chat box so that we can properly welcome you. Thank you. Hello? All right. This is Quarantine, and it says this journey from Ugeli SP section 104. You are welcome, Quarantine. It's nice to have you here on the join us on the call with us. Thank you so much. Okay, so without wasting much time, without further ado, I would like us to kickstart the session. My name is Juliana Ujainika. I'm the ALP lead for SP World Section 104, and I'll just be filling instead for Chizobam pending when his network gets stable and he'll join us. He's supposed to be the moderator for the session. Okay, so moving on. Today I just want to take us through the order of events for our program today. The program of events for today. For today, we'll be having the moderators welcome, just like I've done, and our safety moments will be taken by Faith. She's one of our student collaborators. She's from Nile University. And after that, we'll be having the opening remarks for one of our senior professionals in the section, the person of Mr. Dolapo. And after that, we'll be having the icebreaker session. This will be taken this will be taken by Mohammed Musa. He's from BUK University, one of our collaborators. And after that, we'll be taking the introduction of guest speaker. This will be taken by Okante Wujud. He's from Nile University, another of our collaborators today. After that, we'll be having our amazing lecture. And this will be taken by one of our YPs here with us, the person of Mr. William Okon. And we'll take the photography session, the Q&A, Slido quiz, where we'll be having amazing prizes to be won. So please don't go anywhere. We have cash prizes for the best top 3 winners, and we'll be taking your announcement. This will be taken by Abby Gift. She's from one of our collaborating chapters. And lastly, we'll be having the closing remarks. This will be taken by our YP chair SP Worry session. Okay, so moving on, I would like to invite the person of Faith Tana to help us with the safety moments. Faith, if you're on the call, please kindly unmute and go ahead.
Good evening, everyone. Thank you for joining this meeting today. I hope you all had a wonderful day. So before we start the event, I would like us to go through the safety briefs, because although we are online, we still need to make sure that we're in a comfortable and safe environment. So first of all, before we speak, in order not to interrupt whoever is talking or the speaker, we should raise up our hands to speak. Secondly, can you hear me, please?
Yes, loud and
Yes,
clear,
sorry.
please. Go ahead.
Okay. Secondly, let's also make use of the chat buttons. If we have something to say or we have a question to ask, it's down below the highlighted chat. Thirdly, if we want to unmute ourselves, sorry, I can't see the slide. We need to also maintain a good sitting position in order not to sprain our backs, so we wouldn't have problems after. We need to be at alert and aware of our environment at all times while in the meeting, while during the lecture. We need to ensure that our headphones are not loud, so we can also hear what's going on around the environment too. And then finally, please let's all stay safe. Thank you very much.
All right, thank you very much, Faith. Thank you so much for that amazing safety moment. Indeed, to overemphasize the importance of safety, even though this is a virtual program, we should also be safe. All right, moving on. It's time for the opening remarks, and this will be taken by one of our senior professionals in the SP Worry session. He's our publicity chairman, the person of Mr. Dolapo. Odini. Sir, please, if you're on the call, kindly unmute and go ahead.
All right, Juliana, thank you very much. Good evening. Please confirm you can hear me.
Yes, loud.
Okay, excellent. Good evening, everyone. And thank you for the opportunity to deliver the opening remarks. I'll be doing this on behalf of my fellow board members in Section 104, representing the section chair, the programs chair, and every other notable board members. I actually count this a great privilege coming to do this, and most importantly, having to be the person to deliver the opening remark where the presenter is also someone I know very well, William. And I'm also glad that after leaving school, he's coming back to do this. So kudos to you, Williams, and to everyone that has planned this. To speak to the topic of today, it's important we know that the energy industry is a full chain from the upstream to the downstream, and that in Nigeria currently, both the upstream, the midstream, and the downstream are receiving a lot of focus from the government and international bodies with huge investments in our LNG and a refinery business recently. And I'm sure most of you are aware of that. So, and that's why today's topic is very important. Again, the presenter has first-hand knowledge of this topic, and this ALP provides a first-hand opportunity for you guys to understand what the NGL extraction process is all about. So I'll just employ you to listen, to learn, and ask questions when you have the opportunity to do that. I'm sure that by the end of this presentation, you'll have gained one or two knowledge in addition to what you have already. And I would like to say that I wish you guys a very nice ALP. And in the coming years, I would like to see participants on this call also deliver ALP lectures across the country and globally. Thank you very much. Have a nice one.
All right. Thank you very much, Mr. Dolapo. Thank you for your kind words, and we look forward to. Please let's give Mr. Dolapo a virtual round of applause. It's such a pleasure to have you here with us. Okay, so moving on, our moderator is back on the call, and I would like to hand over the baton to him, the person of Chizobam. He's from the university, one of our collaborators. Is from one of our collaborators, university from the University of Port Harcourt. Okay, if you're on the call, Chizobam, please kindly unmute and you can go ahead from here.
Okay, thank you very much for the warm invite. Good day, everyone. I'm Chizoman Krishiki, and I'll be the moderator for this event today, or this what's it called, meeting on the entry. And in order to not waste time, I like to delegate someone to share my screen because of what's it called, my inability to share the screen at the moment. I had a little hiccup, so if there's a previous time, so whoever can, yes, beautiful. That's awesome. Thank you so much for sharing your screen. Okay. We are at the 13th minute. So what we have next on our item is the icebreaker, which be taken by what's it called? I need you to navigate to the part where we have the icebreaker on the slide. If you do that for me. I want to thank everybody for making our time to be here. And I want to assure you that your time here on this call will be very rewarding. You'll get to learn the extraction process involved in natural gas liquids, and you would leave here a different person from how you came. So our fingers are crossed and our hopes are high. So what's it called? I would like to call on the person taking the icebreaker to kindly step forward. and lead us on the ice breakage. Thank you. The icebreaker.
Good evening, everyone. Thank you for joining us this evening, and my special gratitude to the collaborating chapters and the SPE Wari section for this wonderful program. My name is Muhammad Musa Muhammad. I'm the president of the Society of Petroleum Engineers, Bayer University Constituent chapter. I'll take you through the icebreaker, which I'm sure will be a kind of a shaper or a kind of recharge ahead of this wonderful, highly trending topics with a speaker with vast of experience. So let's go. The first riddle. One, please, if you know the answer, well, it would be good if you like. If you know the answer, just drop it at the chat box. So you can see, and it's on time. We can see how fast you can respond to this. As engineers, we are used to it. I'm sure it will be very simple for all of us. Number one is, please confirm if you can hear me. Confirm if you can hear me, please.
Perfectly fine.
Okay. The first one is, I am full of holes, but still always.
Okay.
Please kindly hold on. Please kindly hold on. Kindly hold on so we can share the screen.
Okay.
Sorry about that. Just hold on.
Okay.
Was just sorry for that. Just having technical issues.
Okay. So, I would like to invite Mohammed back to continue.
Can you share with somebody who can easily share that? So this doesn't take so much time.
Yes. Continue sharing the screen shortly. Thank you. All right, apologies for the delay. So we are back and we'll be moving on to the icebreaker session. Thank you.
Please go.
The condition. I'd like to take the icebreaker.
Okay, good evening, everyone. I have introduced myself earlier. My name is Muhammad Musa Muhammad. Please, can you confirm if you can hear me? Anthony, confirm if you can hear me, please. Okay, my name is Okay, my name is Muhammad Musa Muhammad. I'm the president of the SPE BUK chapter. It's nice meeting with you and ready to engage in this meaningful webinar and lectures from one of the people with the vast of experience. I'm sure this topic is going to bring enough of understandings and it's going to clear enough of doubts, especially with those who have even a little experience in the dynamic oil and gas industry. Let's go on. Let's recharge before the main lecture started. Let's go to the icebreaker, please. If you have when after the question is read, just feel free to drop the answer at the chat box. I'm full of holes, but I still hold water. What I am? Wow, somebody is saying sponge. Sponge. Nothing again. What about reservoir? I thought some people would say something like reservoir because I thought many of you are petroleum engineers. Okay. Any different idea again? Sponge, pump. Somebody is saying pump. Wow. Uh, Divine. Where do you say pump? Unmute and let's hear some of your view on this. Wow. Fabric.
Can you hear me?
Can you hear me?
Yes, I can hear you.
Basically, it's just like if you put it from
If you
water,
put it from water,
but it can still hold a lot.
it can't be put again.
Yeah, it can hold, but not tangible amount.
Exactly.
Exactly.
Yeah, okay. So yeah, I like this one. He says a porous reservoir. I think more of that, but it's a response to this technically one. But as petroleum engineers, the first thing we think is a reservoir. Because how the boys can hold water. Maybe if it just like it holds oil when all the petroleum system elements are present, like the presence of the reservoir and also the trap that presents further migration. That's good. Sponge is the correct answer for this one. Let's go to the next. Thank you. Let's go to the next, please. The next slide. I'm not alive, but I can grow. I don't have lungs, but I need air. What am I? Wow. Let's see who can. Wow. Divine. Divine always respond on time. Air. Fire. Okay. Any different view? Let's see if you can have a different view. Everybody says fire. Is it only fire that needs air and can grow? So you are correct. Divine, Omaka, you are all correct. Thank you. Let's go to the next one on time because we have little time. The next one is I move fluids, but I have no hearts. I can be centrifugal, opposite displacement. What am I? I'm sure process engineers and production engineers will guess this. Very simple. Pump. Let's go to the next one. I move fluids, but have no hearts. I can be centrifugal. Not pump again. I move fluids, but have no hearts. I can be centrifugal or positive displacement. Of course, it's separator. So if there are 3 apples and you take away 2, how many do you have? Of course. How many do you have? The last one.
Thank you so much. Thank you so much,
The person with the most
Mohammed.
answers. You are correct. You will have 2 because
Thank you so much, Mohammed.
have a good lecture. Thank you.
Yes, a plausible chair by Mohammed. I want to thank you for taking this session in the best way possible. We'll have to move on from here. The next item on our list is the introduction of our guest speaker that will be taken by our very own Mr. Okatenwo Jude. So if you're on the call, we would like you to kindly unmute your mic and take the introduction of our guest speaker. Thank you. Mr. Jude, if you're on the call, would appreciate it if you take the introduction of our guest speaker. The introduction of our guest speaker is the next on the item.
Okay, Sammy is trying to unmute. Judy, if you can hear me, please kindly go ahead.
Okay. In the interest of keeping to time and in the interest of
Um,
an interest of keeping things on the
okay,
rabbit, I'll
all
take
right.
the introduction.
So please go ahead. Please go ahead.
Okay. I would like you all to meet our guest for today, our guest speaker who will be gracing this call with sound words of wisdom, sound words of intellect, and profound knowledge in petroleum and gas industry is none other than William Okun. William's Wisdom Okun. William Wisdom Okun is a distinguished graduate of the Petroleum Training Institute, a full-run Delta State, where he specialized in petroleum engineering, technology, a strong expertise in rig and well operations, offshore production, process safety, and gas compression systems. He has gained practical experience with Seplat Energy as an operator rather trainee, where he worked across the spectrum of upstream operations, including wellhead controls, offshore production facilities, rigging operations, turbine systems, separation processes, waste heat recovery units, gas compression platforms, and NGL extraction facilities. This exposure has deepened his technical expertise in both offshore, onshore, and offshore environments. A proven leader, William served as president of the Society of Petroleum Engineers (SPE) student chapter at PTI 2022 to 2023, where he championed technical engagements, student development, and industry collaboration. His dedication earned him the Best Student Volunteer Award, SPE Warri Section 104 2023, and the SPE African Regional Student Chapter Recognition Award in 2023, affirming his impact on the energy community. Driven by passion for energy, innovation, process safety, and sustainable petroleum operations, William is committed to advancing excellence in oil and gas facility management while contributing to global energy solutions. A warm welcome to our guest, Engineer William Wisdom Okun.
Yeah, thank you very much for the introduction. Good evening, everyone.
Good evening, sir. You're highly welcome, sir.
Thank you very much. Please, I hope you can hear me loud and clear.
Perfectly fine, sir. You are the best.
All right. Please confirm you can see my screen.
Yes, we can. We are seeing you clearly, sir. Very clearly.
Okay. So going through this topic, NGL extraction process, leveraging distillation and fractionation for optimal product quality. I will be keeping it very simple, and I want to believe that not everyone here has a basic understanding of NGL extraction process, and maybe not everyone is an engineer or has the field experience. So I'll be keeping it very basic and simple, just so everyone can follow through. So when we're talking about natural gas liquids, the NGLs now, natural gas liquids, they are hydrocarbons that are extracted from the raw natural gas, which can be liquefied under moderate pressure and cryogenic temperatures. So what do I mean when I'm talking about cryogenic temperatures? We're looking at extremely cold temperatures. So what are the major components of these NGLs we're talking about? We have ethane, propane, butane, isobutane, pentane. So in the course of the discussion today, I would like to be making use of some jargons, I'll be calling ethane C2, propane is C3, butane C4, and so on. So in case you hear me say C2, C3, and C4. So I'm just trying to refer to the ethane, propane, and butane gases. So why do we want to fraction, or should I say distill these gases? Why do we want to get fractions of these gases? It's because they are more valuable when they are sold in fractions, right? Rather than as a raw mix of hydrocarbon compounds. So if I'm taking out ethane to sell, it's more valuable than when ethane is in solution with other hydrocarbon compounds. So now basic principle of distillation. So what is the major thing when we talk about distillation, what are we trying to say? Now, I will use a very simple illustration before we take a look at this illustration. Basically, let's use this common phenomenon that we all are used to. Your pot in your kitchen, you place it on a cooker, you fill it with water, place it on a cooker, and you begin to heat up the water, right? What happens? We start having bubbles formed under the bottom, right? These bubbles at a certain temperature, they begin to vaporize. You have vapors coming out. That's just you boiling off the lighter compositions in that liquid phase, boiling off the lighter composition off the top, right? While the liquid still remains at the bottom. That is distillation. It's just separation using boiling points. It's simply distillation, is separation using boiling points. So I don't know if everybody understands up to this point. I'll need responses.
Maybe it's one more
I'll
time.
need
Yes, sir.
We're following, sir. We're with you, sir.
All right, thank you very much. So we're going to go further. So for fractionation, it's just a distillation process using boiling points, right? To boil off light ends from the heavier ends, just as I have said. So you would hear me use deethanizer, depropanizer, debutanizer, deisobutanizer. Now, when we in fractionation, each fractionator is named for its overhead product. So if maybe I am fractionating or distilling, separating a product, what is going off up top? If it's methane, that means that column is a demethanizer. If it's ethane going up top, that column is a deethanizer. If propane is what is going up top, that column is a depropanizer. So it is named based on its overhead product. So we're going to look at this simple process flow. In NGL extraction, it starts with your gas preparation. NGL extraction processes, you have to start from your feed gas preparation. So what does the feed gas preparation entail? The feed gas preparation entails your gas treating and conditioning. Gas treating and conditioning. So if you look at my screen here, so your gas treating and conditioning, this is the section I'm talking about. So when you talk about gas treating, what do we mean? Now, for a certain product, there is supposed to be a standard or specification for, should I say, allowable amounts of contaminants in your product. And this varies from one plant to another based on standards and customer requirements. So what are we talking about? Let's say I am producing from a reservoir, and I know you need to know your gas composition, right? I should know the amount of maybe ethane to propane ratio in my gas stream. I should also know, okay, in this gas stream, am I having sulfur? Am I producing sulfur as well? Is mercury part of this? How much water vapor content do I have in this gas stream? Now that would now determine my gas treating and gas conditioning process. So look at this. You see that the gas treating process, we have CO2 and H2S to be taken care of. So how do we take care of H2S? You know, this poisonous gas, right? And they are contaminants in our NGL products. So you can take care of this using amine units. Amine units will take care of your CO2 and H2S content in your gas stream because you don't want to sell this to your customer. Now, your dehydration process will take care of your water vapor, and the mercury removal beds will take care of your mercury. Why are we taking out water vapor from the gas stream? Can anybody give an answer to that question? Sorry, I want to make it interactive. So, do you know why we'll be taking out water? Why do you think we'll be taking out water vapor from the gas stream as part of the preparation process? You could answer in the comment section in the chat room. There's someone said it could cause corrosion. All right. What else? That is correct. It could cause corrosion. I need more information. There are more. Why are we taking out water vapor from the gas stream? Because you're selling gas, not water. All right. Someone says because you're selling gas, not water. All right. What else? Okay. To improve quality. All right. We need dry gas products. Okay. So we are all correct. But again, remember we stated that we are doing this using cryogenic temperatures, right? So what do you think in a very cold temperature operation, right? You send in your gas with water vapor content. What do you think will happen? Okay, someone said it also prevents hydrates, avoid hydrate formation. That's okay, that's beautiful. So we are dehydrating because we want to prevent hydrates from forming. What is this big English I'm saying? Water vapor, if we send them under this cold temperature region, what will happen is it will basically freeze the line. If it freezes the line, it will block your line. That means there will be no flow, right? Little or no flow. Then that will affect your process. Then if there is little or no flow, and it can also cause damage to, equipment, right? So that's why we're taking care of the water vapor. Then why do you think mercury is a concern? Can someone help me? Why do you think mercury is also a concern? Why do you think mercury is a concern in the gas stream as well? It reacts with metals. Okay, beautiful. Mercury reacts with metals. All right. Beautiful. That's beautiful answer. That's from Joy. All right. So if this your gas exchanger that you're looking at here, right? Your condenser you're looking at this point, and probably your reboilers. Some of them they are made of aluminum, right? Then with this aluminum, if mercury will dissolve aluminum over time, so therefore damaging that equipment, right? So we don't want mercury going through our gas stream. That's why we have maybe make provisions for mercury removal beds. Again, all this treating and conditioning process is depending on your gas composition, right? That's what is going to determine your feed preparation. So after the feed preparation, we go into cooling and expansion. Please take notes because while I'm explaining this process is when we go further, you would understand why we discussed about this first. Okay. So the cooling and expansion process is also very key. That's the second stage when we are talking about the NGL recovery, right? Remember, we are liquefying this the natural gas from the original natural gas mix, right? Under cryogenic temperatures and moderate pressure conditions. Excuse me. So there is a gas exchanger here for your feed gas. So you see there is this gas stream going through your gas exchanger exchanges heat with another fluid going through this other pass. So we'll look into that further as we progress. So that heat exchange that takes place here, it does what? Sensible and latent heat. So what do I mean by that? It affects the temperature of the product and as well changes the state of your product. So at this point, going through your gas exchanger, we are supposed to begin to have some products condensing. That's why we now have the next item here or equipment here to be an accumulator. You can call it a cold separator, whatever you want to call it, based on design. So this can be an accumulator, it can be a separator, whatever you want to call it. So that what the products that have gone through here and exchanged the heat has started condensing, it comes into this accumulator or separator that provides residence time for the liquid and vapor to separate. So definitely liquid is going to be at bottom while your gas is going to go up top. So the expander, take notes, your expander is very key in your process. Why is it key? We have cooled some of the liquid, we've condensed some, but then we still have so much vapor here, right? So what's the function of your expander? The expander is operating based on isentropic expansion. Isentropic expansion. What do I mean by isentropic expansion? This expander spins the gas rapidly. So, can somebody tell me, if I increase velocity, what effects does it have on temperature and pressure? When I increase velocity, what are the effects on temperature and pressure? All right, so increased velocity is going to result in reduced pressure, reduced temperature. Thank you very much. So spinning my gas, this expander also, it takes the energy from the gas to drive another component, which we call the compressor. So that energy taken from the gas and spinning this gas rapidly, now it reduces temperature and pressure so much that your gas, it brings it to the dew point temperature, reduces your gas to the dew point temperature, whereby condensate, your liquid begins to form. Your gas turns to liquid because temperature has reduced, pressure has reduced, the energy is lost, gas becomes liquid. Please, I don't know if you follow up to that point.
Come again,
Yeah,
please.
we do.
Come
Yes,
again. Come again,
okay.
please.
When I spin my gas, I'm increasing velocity and I'm doing it so rapidly. And the expander is taking the energy from the gas to drive a component here, which is called the compressor. So by doing so, the pressure and temperature of that gas has been taken out, have been reduced so much because no work again is done by the gas. The energy from the gas has been taken and is spinned rapidly. So you now begin to have liquid forming. Do you get up to that point?
Yes,
Because
yes.
it had been reduced to its dew point temperature. So what's dew point temperature? It's the temperature at which liquid begins to condense out of the gaseous phase, right? So that's for the expander. So this is a typical, let's call this your de-ethanizer. I'll be making reference to your de-ethanizer this time. So this is your typical de-ethanizer, which we'll be looking at as we go further. I wouldn't want to bore you with all of these processes right now because we are still keeping it really basic. But you would understand more as we progress. This is a typical fractionation column. So I want you to see what a fractionation column looks like. So this fractionation column, what are we really looking at? You know, we've built up to this point. So we are trying to remove one or more lighter components, fractions, from the major stream, right? We are removing lighter fractions from the major stream with a fractionator column. Now, the internal trace, we can identify internal trace here. These are trace. So take note, some fractionators can combine trace and continuous packings as well. So what are we, why do we have internal trace in the tower? Is to promote close contact between the rising vapor and the falling liquid in your column. So that's why we have this series of trace in your column. All right, so this is the feed stream. So the upper tray is called enriching or rectifying tray. Your lower trays are called your stripping trays. Then where you send your feed in, those are your feed trays, just at the middle. We have a reflux accumulator, a condenser, and a reboiler. So these are major things you have to look out for in any fractionation column. So what's the essence of this? I'm trying to boil off light end from the liquid here. So what I want going up is just the light fractions that I do not want in my NGL products that I'll be sending out. I want to boil off those light fractions up. Take note, hot A rises, right? Hot A always rises. So when I boil it off, it's hot, the vapor begins to rise. When it rises, it comes to a condenser. Again, change of temperature and change of state. So that vapor that has gone off is liquefied by the condenser, is cooled down and liquefied by the condenser, and is collected in the reflux accumulator, then pumped back into this unit by your reflux pump. What is responsible for the heat to drive off the vapor is your reboiler. Your reboiler is a shell and tube thermosyphon reboiler. Your heating medium is going through the tube while your NGL product is flowing through the shell side of your reboiler, assisted by a weir. Now, what do I mean by a thermosyphon reboiler? It's very simple, right? A thermosyphon effect. Who knows what a thermosyphon effect is really all about? Can someone help me? If there's no, if you know it, you could just quickly say, or we progress. I can say. All right. Okay. I assume no contributions for now. So when we hit up your NGL products, right? The bottoms products, when you heat it up using the either steam or whatever heating medium to heat it up, it reduces in density. That is, density decreases. Once density decreases, what happens? The buoyant force that is pushing this upwards becomes stronger than the weight of the liquid. So, which makes it easier to push up your liquid back into your fractionation column. And because there is a temperature differential that has been formed, your bottom product is able to flow to refuel whatever is going out by gravity due to that temperature gradient that is created. So the buoyant upward force becomes stronger when density reduces. So because density decreases, the buoyant upward force is enough to overcome the weight of the liquid, therefore pushing it upwards into your column. So it continuously flows and is a closed cycle. So the level in this liquid is usually controlled by a level controller. So that's for another day, right? We will dive into that as we go further. So to achieve top product quality in NGL recovery, I felt it would be necessary for me to take you through what the Otlov score process is really all about. What is the score process? It's the single column overhead recycle process, which is an advanced cryogenic distillation configuration developed by the Otloff engineers, right? So it's a patent technology developed by the Otloff engineers. So you could see people, if you want to do a top design for NGL products quality, they are very, very okay, and they give very good designs. Now, why did I introduce you to the Otloff design process? It's because they maximize ethane and heavier hydrocarbons recovery from natural gas while reducing energy consumption and equipment count in the process. So, what do I mean by this? The Otloff process, it encompasses energy optimization and also purity of the product. So in trying to maximize or in trying to conserve energy in a process, they also achieve product purity or product quality. Yes, to
Okay, unavoidably, unfortunately, rather, we've lost contact with Sir Williams due to his internet connection, perhaps. But as far as the ambassador lecture has gone, okay, he's back. He's back. You can continue, sir. Can continue. To honor his involvement as the guest speaker, we would have to give him 2 minutes um, to wait.
I think he's muted. Willing to just speaking your muted.
Oh, my apologies. Sorry. Can you hear me now?
Mhm. Yes, very you.
My apologies, please. Nigerian network for us. Please, where is the last point you followed through to, so I could know where I'm starting from?
You just introduced the Outlook process as being a patent technology.
Okay, sorry about it. Thank you very much. Yeah, so the Otlov process, the Otlov score process is more effective. Why? Because in energy conservation, it's also able to achieve product purity, right? So this is done by controlling the reflux ratio. In controlling your reflux ratio and the pressure in your deethanizer column, you're able to tune your product purity. So I'll explain this as we go further. So what is another key thing about the Otlov process? With the Otlov score process, you're able to get, for a deethanizer column, you're able to recover 98% of propane from that column. Just leaving with 2.0 more percent of ethane composition, right? Which again, the design varies from plant to plant, depending on customer requirements and industry standards, right? So, but it has the ability to give you up to 98% product recovery, NGL product recovery. So let's quickly look at this process. This is a typical Ortloff process. Now, look at your column. You can see there are many inlets. Let's count. We have 1, 2, 3, 4, 5, and 6. Then we can also count the number of outlets from the columns. We have 1, we have 2, we have 2, right? So we have 2 outlets from your column. 3, sorry, your bottoms angels is the third outlet. So you understand why the Ortloff design is like this. So I'm going to start like from your inlet gas stream. Remember that your gas coming in is hotter. So there's supposed to be heat exchange, right? So it's supposed to come in and be cold. It's supposed to be cooled in your inlet gas exchanger. So the Ortloff design now gives you the ability to conserve energy, right? You use the cold feed to exchange heat with the hot feed, and that's very flexible design, right? So if you look at this, the boiler has provided the heating your ethane from your propane plus composition, which is your NGL product that you want to sell to your customer. So ethane is going up, right? This ethane going up, this is your overhead product. Ethane is your overhead product in this de-ethanizer column. The Ortloff process makes use of the side draw to get your reflux. So what is coming out here? Remember, temperature in a distillation column decreases from bottom to top. So it is hotter at the bottom and cooler up top. So once my feed comes in, it gets boiled off, the ethane goes out as the overhead product. What I'm supposed to be having flowing through as my bottoms product should be my propane plus NGL composition. Now in this state, I want to have 98% of propane as my NGL product. So if I should see ethane at all in my product, ethane or other lighter composition like methane, it should be only 2.0 more percent in my 98% product. To achieve this using the Ortloff process, all these controls and conditions are put in place. My reflux side stream goes through my overhead condenser. This overhead condenser, again, latent heat and sensible heat is being taken care of here. Change of state and change of temperature. The overhead condenser, the reflux side draw exchanges heat with your overhead product, then comes into your reflux accumulator. The reflux accumulator provides a kind of residence time for vapor and your liquid to be separated. We want vapor going up while your liquid is going to go to the bottom. So the liquid reflux will be pumped by this reflux pump into your column. Why am I doing this? We want to create a countercurrent contact between rising vapors and the falling liquid. So if my rising vapor, for example, if I have eaten this product so much that let's say some propane is escaping with the lighter ends of going out with the overhead product up top. With the help of this reflux, and you can see the reflux is split into 2 streams. So this reflux is to give that countercurrent contact so that the heavier composition in your lighter end can condense off and fall back to the bottom of the de-ethanizer. So your reflux is being ratioed One is fed to the top of your rectifying section, while the other is fed to the top of your stripping section. I don't know if anybody is following me. Please let me get reactions if you're following. All right. So, all right. So with that split stream, we're able to account for product quality. That means I am not losing propane as my overhead products. I'm not losing propane up. So I want my propane as much as possible. I want them to be at the bottom, going through the bottom, because that's what I'm selling. Right? Then there is provision for another side drawer. Again, see what they did for heat exchange, energy conservation, and for product quality. So the heat is exchanged. This other vapor is cooler. It exchanges heat with your inlet feed stream. Then going back is going to come back warmer and hotter, right, into your stripping section. Remember, the stripping section is heated so that we can drive off as much ethane as possible. We are trying to acquire or achieve product quality in this state, right? Your liquid from your cold separator as well is exchanged. Again, the cold sep liquid exchanges its heat here with your inlet feed stream as well. It comes back warmer into your stripping section so that we can boil off as much ethane from the propane plus composition. Remember, we want to meet product specifications when we are looking at NGL extractions as well. So that's why there are many controls we also put in place. If for example, I am operating this unit and I discover that, okay, sorry, I not mentioned that we make use of maybe a chromatograph or analyzer to monitor the ethane to propane ratio in your, for example, your deethanizer column. You are monitoring your the ethane to propane ratio. We don't want to have so much ethane, more than 2.0%. Like that's my requirements, right? As a customer, I don't want to have more than 2.0 more percent of ethane in this composition, right? So maybe the operator is operating and he sees that there is so much more percent of ethane in the composition. What do you think will happen? They have to start playing around with temperature. We should heat up more. It may infer that, okay, the temperature is not enough to boil off the lighter ends from your AVR compositions, right? So it's either you open the flow of your heating medium more to heat up more, and to achieve that bottom temperature, that you need to strip off the vapor from the AVR components. So, and in a case whereby I begin to experience flooding, I have to begin to rationalize or to regulate the amount of reflux again, and the feed stream, right? So that I don't flood my my column. In a case whereby your expander is not working, or you are starting up your plant, your expander right now is not running, how do you cool off the gas? What is the effect? There is what we call the Joule-Thomson effect. We make use of Joule-Thomson valves. The valve will be provided to bypass this section, right? So with the aid of that valve, it provides this adiabatic expansion. What do I mean? It's just using basic Joule-Thomson effects. It's not taking the energy from the gas to drive anything, right? So as the gas is going through those restrictions, pressure drops and temperature drops. Now, the resultant effect is that your column will be operating at a much more higher temperature and pressure condition compared to when you were operating with an expander. So with that being said, that means you have to make adjustments to temperatures and pressure conditions for you to boil off just the necessary ethane components, right? And recover as much propane plus components. So But using a jetty valve, your product's quality may reduce to as much as 60% propane recovery because of the higher temperature and pressure conditions, right? So that will affect the process. But then it's just for the time being until your expander is brought back in service. So many other controls like that, but we don't have so much time to talk about them now. Maybe we'll have a next series that we could do justice to that. So your engine extraction enhances gas value. Distillation and fractionation ensures separation precision. Then process control ensures product quality and energy efficiency. So with this, we've come to the end of this session. Thank you very much for your time, and I hope I've been able to impact.
Yes, yes, yes. A wonderful presentation. That was a wonderful ambassador lecture by our very own engineer William Okun. We can't thank you enough. A virtual round of applause to him. It was indeed a thrilling and exciting and insightful session. We can't appreciate you enough for this wonderful presentation. All right. The next item on our list is the part where we take a snapshot at the initiation of our body slogan, which is SP Cleaner Energy. I would want each and every one of us present on this call to turn on their cameras so that you can be seen on the Zoom interface. So if you're on this call, I would like you to turn on your camera, and then a snapshot will be taken by our very own Mr. Imos. Mr. Imos will be taking the snapshot for this section. So please turn on your cameras. Beautiful. I can see some people are turning on their cameras. Please turn on your camera so that we can move on to the next what's called I'm still waiting for a few other people. Once we are complete, we'll say the slogan cleaner energy and then the snapshot will be taken. So until the greater lot of us has turned on the camera, we'll take the snapshots. So I'm waiting on you guys to turn on your cameras. Beautiful. I can see a lot of people are turning on their cameras. So Sir Amos, I would like to get an emoji response from you indicating that you're ready for the snapshot. I believe the other people who have not turned on their camera at this point in time have their reasons. So
yes, I'm ready.
Okay, beautiful, beautiful, beautiful. So we'll all say okay, all right. So you're ready. All right. SP Cleaner Energy.
To reiterate, it's now solutions, people, energy, right?
Yes, yes. So, Emo, has the photo been taken?
Yes, it has. It has been taken.
Okay, beautiful, beautiful. Thank you so much for assisting us on that. Okay, moving on, we would have to hasten things up a bit. The next on our item, the next on our list, would be the question and answering session, which will be taken by our very own Secretary General from the BUK chapter of SPE, Comrade Mohammed Bashir, will be taking the questions and answering section. So based on what you've learned, based on what you've assimilated from the ambassador lecture. If you have any questions, if you have any concerns, if you have any findings to make, or if you have any misclarity, or if you're unsure, uncertain about what has been said, if you weren't given the opportunity to speak your mind while the lecture was going on, now is your time. Sir Mohammed, please take the floor.
All right. Thank you so much, Chizovam. Good evening, everyone. My name is Muhammad Bashir Abakar, the Secretary General of SPE BUK, and I'll be coordinating the question and answer session of these lectures. Thank you so much, Mr. Williams, for the wonderful and great lectures. I think if anybody has a question, you should leave it in the chat box for Mr. William to answer. Can you hear me?
Yes, we can. We can very loudly, loud and clear.
So please, everyone should just put their questions down in the chat box.
All right, while we are doing that, let's confirm you can hear me.
Sorry, what did you say?
Confirm you can hear me.
Yeah, we can hear you, but lightly.
Okay. Please, Amos, kindly make Kachi a co-host. Thank you.
You were saying something. Please, if you have any question, put it down in the chat box.
All right, please confirm you can hear me.
Yes, we can hear you.
All right, thank you very much. Thank you to amazing speaker for that. While we're waiting for questions, I would like Mr. Amos, please kindly make Kachi a co-host for this. If you can hear me, Amos, please kindly make Kachi a co-host. Thank you. Please, if you have questions, you can drop it in the chat box or
Yeah,
signify by
someone has.
raising your hand and go on from there. Okay, thank
Someone,
you.
I think there are a few.
I think there
There are
are
a
a
few
few
questions.
questions. Yeah, a few questions.
Raised
Okay, we can just
from
take
the.
2 or 3 for the sake of time and we'll wrap it up from here. Thank you very much. Thank you, Mr. Amos, for that. And please go ahead. Go ahead taking the question.
Okay. So, Mr. Amos, the first question, which came from Joy, she asked, how do we handle hydrate formation if dehydration isn't effective?
All right. Yeah.
Mr.
Thank you
Williams.
very much. Yeah. Confirm you can hear me, please.
Yeah, we can hear you loud and clear.
Yeah. So as much as possible, to prevent hydrate formation, we make use of your dehydration processes, right? And you should be these processes, we look out for the dew point temperatures. It should be so effective. Most times we encourage the use of emulsives. But say with everything being done, you still experience hydrate formation, right? You use a mitigative plan, which will be injecting methanol. So why are we injecting methanol? It's just I want to raise the temperature so that for example, let me just give a very simple illustration. You have ice cubes, you put it in a pot and you begin to heat it up. What happens? Your ice cubes will melt, right? So injecting methanol is just to raise the temperature so that your hydrates can begin to break off, right? So, but it's a more of a mitigative standpoint, while the dehydration process is a preventive standpoint. Thank you very much.
Thank you so much, Mr. Williams, and I hope your question have been answered, Joy. So the next question comes from Yusuf Mansour from Chemical Engineering BUK. He mentioned that he needs more clarification on Otloff score that was mentioned by you, Mr. Williams.
All right, okay. So for the Otloff score process, it's basically recycling processes. Remember, I showed you different inlets and outlets from a single column. But in a normal fractionation column, you will not have this many outlets and many inlets, right? So but the Otloff score process is a single column overhead recycle, just using many recycle processes. What's the main aim? In as much as we are operating, we don't want too many equipment. We want to conserve energy and achieve product quality and purity at the same time. I don't know if that's explanatory.
Yes, I think it's well explained. I hope your question has been answered, Mr. Yusuf. So the next question comes from Eseverere Carrington, where she asked that you mentioned that using JT valves as a contingency solution in case of expander failure. What can be a contingency plan if the reflux pump fails? Mr. Williams, is the question clear?
Come again with that, please. I lost you for a moment.
Okay. Here she asked that you mentioned using JT valves as a contingency solution in case of expander failure. So what can be a contingency plan if the reflux pump fails?
Okay. So, right, in facilities and in designs, you cannot have just one pump running, right? I mean, just one pump in place. So sometimes they might make provisions for 2 to 3. If provisions are made for 2, one will be running while one will be on standby, so that in case one has to go on maintenance, the other one can take over. So it's usually wise or unadvisable in any facility. You cannot see a system operating with just one pump. I mean, just provided with just one pump. So one pump will be operational at the time while one will be on standby, right? So that's just it. Yeah.
All right. Thank you. Please, can we go ahead for the sake of time?
Sorry, I lost you guys.
Okay. All right.
Okay.
Thank you very much for the sake of time. Thank you, Mr. Williams. Such a pleasure to have you speak to us on such a technical topic. Thank you, Mohammed Bashir, as one of our
My
collaborators
pleasure.
from the UK. Thank you. All right. Okay. So moving on, it's time for the interesting part where prizes will be won. Please, Chizobam, can we just go ahead? Kindly
All
introduce
right,
the
all
video
right.
quiz. This will be taken by one of our white. Go on. Please, let's try to wrap it up. Thank you.
Yes. Thank you once again for the counteractive what's it called, question and answering session. You did a wonderful job. For the sake of time, we would love to move on with the Slido quiz. I think this is the most interesting and rewarding part of what's called um, meeting, and it will be chaired by our very own YP of SPE Worry section. He's none other than forgive my pronunciation, Mbeji Oyedika. We'd love you to take the Slido quiz section of our meeting. Thank you so much as you come on board.
Well, thank you very much, Chizoban. Good evening, everyone. My name is Onyedi Kachi, and I'll be anchoring the Slido quiz. Before I begin, I would like to thank our speaker, Mr. William. He did justice to that presentation. He's my friend, and he's really capable and did a lot to it. He really took care of this. Thank you very much, William, for sharing your knowledge with us. So we are going to start our Slido quiz now, and I'm going to send an invite to everyone. So all you need to do is just to check the chat box and accept my invite. I hope we can all hear me. Can everyone hear me? Or can anyone hear me?
Yes,
Yes.
we can hear you.
Yes,
So I've sent an invite to the chat box. So just open the chat box and accept the invite so that I'll be able to participate in the quiz. So there are prizes to be won, there are cash prizes to be won. So if you perform well, we are picking the first 3 winners. So if you perform well, you win a cash prize. So let's go. I've sent the invites to the chat box. So just click on the chat box, accept the invite. I'll be able to participate in the quiz. Okay, I have 6 people now. There's the chat box in this Zoom call. Go to chat. You'll see an invite there. Accept it. That's all you have to do. You have 10 now. We are at 36, so let's accept the invite. So while I'm waiting, I'm just going to brief us on what's going to happen in the quiz. So we have 10 questions. Some questions are from the topic from today, while some are general questions. So you have limited time to answer the questions. You have 15 seconds to answer each question. And the faster you answer, the more points you earn. So I'm going to resend the invite to everyone so that I've resent the invite. So you go to the chat box and accept the invite. That's all you need to do. Okay, how many do we have now? 12 participants. All right, so for the sake of time, I'm going to begin the quiz. In case you still want to join while the quiz is going on, just move to the chat section and accept the invite you see there. I'm going to be starting the quiz in the next 30 seconds. So, okay, we are 14 now. And I'm going to reshare the invite one last time so that everybody can have a chance to receive our prizes. Okay, I've resent the invites. And we are going to start now. So let me share my screen. All right, so let's begin. Okay, so our first question. The following are components of natural gas liquids except what? A, ethane, B, butane, C, isobutane, D, dodecane. So everything here can be found in natural gas liquid except what? And the answer is dodecane. You cannot find dodecane in natural gas liquids.
Hello,
So,
Kachi.
yes.
Sorry, I can't see your screen. I don't know if it's just me.
Okay. Let me work on that. Share. Share. Can you see my screen now?
Yes, it's up. Thank you.
Okay. So Daniel Ekeng is leading. Is the fastest to answer. So next question. What type of process is NGL extraction? Is it a cryothermic process, exothermic, cryogenic, or endothermic? What is the answer? The speaker mentioned it, so this should be very easy for us. And the answer is 80% of people got it right. Cryogenic process. So it's a cryogenic process. Daniel is still leading, followed by David Akpabio and Noli. That's very good. A debutanizer can be used for NGL extraction. True or false? This is a trick question, so we have to think properly. Can you use a debutanizer for NGL extraction? Lots of people missed this. The answer is actually false. A debutanizer is used to remove butane from an NGL stream. It is not used to remove NGL on its own. So the answer is false. And David Akpabio is leading now. He's leading, followed by Daniel and Nnadi. Number 4. Which of these is least likely to be found in an NGL extraction plant? Can you find a tank, turbine, heat exchanger, compressor? Which one are you least likely to find? Wow. The answer is a tank. You are least likely to find a tank in an NGL extraction plant because you are dealing with cryogenic liquids and they easily vaporize at atmospheric pressures. So you won't use a tank there. Well, Samuel Innocent is leading the board now, followed by Nnoli and David Akpabio. Number 5, air gets hotter the further you move into the stratosphere. Is this true or false? So if you should go up, will it get hotter or colder? If you should go up into the air. And the answer is true. Now, the stratosphere is where the ozone layer is. So since the ozone layer absorbs heat, it tends to gets hotter when you're in the stratosphere. So that's how it is. And the answer is true. Now, Nolly is leading, followed by David Akpabio and Jude. Nice. The leaderboard is shuffling a lot. Which of these is more volatile? A liquid with a high vapor pressure, a liquid with a low vapor pressure, all of the above, or none of the above. So which of these is more volatile? Which of them will vaporize easily? Okay. The answer is a liquid with high vapor pressure. So anything with a high vapor pressure tends to vaporize more easily than those without it. Nolly is first now, followed by Samuel and David. Next up, what process does the sun use to generate its energy? Solar energy, nuclear fission, nuclear fusion, or combustion? What is the answer? How does the sun generate its energy? Wow. Wow. I'm surprised. The sun generates its energy using nuclear fusion. The energy of the sun is solar energy, but how it does it is nuclear fusion. And the question was, how does the sun do it? What process does it use? So the answer is nuclear fusion. Nolly is leading now, followed by Daniel and Amos. Next question. At what section does significant cooling occur in an NGL plant? Is it the inlet exchanger, the expander, the separator, or the dehydrator? Where do you have the most cooling? Okay. And the answer is the expander. So the expander is where you get a large fraction of cooling, where you get the most cooling in the plant. Now, it's not the coldest area, but it's where you have that a lot of cooling. Just trying to call. Okay, can anyone hear me, please?
Yes, loud and clear.
Okay, sorry, I got my
Yeah, we can hear
network was misbehaving. All right, so we have Nolly leading the board, followed by Daniel and David. Next up, what part of a fractionation column is the coolest? the top, the bottom, the middle, or the outlets? I think this was mentioned when the speaker was talking about temperature gradients. So what part is the coolest? The top, the bottom, the middle, or the outlets? The answer is the top. So the top of a fractionation column is actually the coolest. And Daniel is leading the board, followed by David and Samuel Innocent. Beautiful. And the final question, this is your chance to make it to the top of the board. What layer of the earth is the thinnest? So the earth has a lot of layers. What layer is the thinnest? The crust, the mantle, the core, the outer core, or the inner core? Which one is the thinnest? Okay, let's see how our leaderboard looks like. And the answer is the crust. The crust is actually the thinnest layer. Let's look at our leaderboard. We have in first position Daniel Ekeng from Nile University. In second position, David Akpabio. And in third, we have Samuel Innocent. Let's give them a round of applause, please. Thank you all for participating and see you next time. Daniel, David, and Innocent, please reach out to Juliana for your prizes. Thank you.
Indeed, this was a very exciting and exhilarating exercise. And I want to thank you for a very productive session. So thank you very much, sir. We really appreciate it. Next on our item, we'll have to hastily and unredactedly invite, what was it called, our very own Vice President of SPE Uniport chapter to take on the announcement for this meeting. So my Abby Gift would like to call you on board to take the announcement. Ma Abby, we are with your response. Please take the announcement for the sake of time.
Okay, Chizoba, for the sake of time, if she's not on the call, please can you help us take that? Thank you. Can you hear me?
Okay. Yeah, I
Thank
can
you.
hear you. Yeah. That's good. All right. Okay. Announcement number one. YPSPE Worry presents Ambassador Lecture Program, which is themed Fundamentals of Fire Safety and Protection System, which will be happening on Saturday, 18th of October 2025. Time is 5 p.m. West African Standard Time. The second announcement is that SPE UK chapter, in collaboration with SPE University IU, will be presenting a webinar themed Connecting Classroom to Career, Drilling and Completions for Young Engineers. This will be happening on Monday next week, which is on 13th of October 2025. The time is 4 p.m. West African Standard Time. Then lastly, on our announcement list is SPE BUK presents the first ever BUK Annual Energy Innovation Symposium AEIS 2025, which will be taking place on the 28th and 29th respectively of this month, October 2025. And the time for this is 4 p.m. daily West African Standard Time. So that's for the announcement. Moving on, to keep this very short, sweet, and unredacted, in the interest of expediency, I would like to invite our YP chair for this speak for a section, our very own Mr. Lucky Emyemye, who will be taking our closing remark and giving a very formidable and musical vote of thanks for everyone present here today. So, Mr. Lucky, to you.
Hi, Chizu. Thank you very much. It's been quite an amazing ALP session. I was here from the beginning, and I I watched the speaker deliver a very beautiful session. Um, William Okon. William happens a very close friend. He happens we were both student chapter presidents when we were in school together. He was the chapter president of PTI while I was the chapter president of Novena University. So it's so warming and nostalgic to see that he's here actually delivering a lecture. And thank you very much, William, and thank you for your time and your devotion to SPE. And I would also like to extend my appreciation to the ALP team from the section led by Juliana. Thank you so much for putting this together. And I must appreciate the student chapters who have availed themselves to collaborate on this ALP. I was so impressed with the numbers. I think at the time I saw over 50 attendance. That is one of the highest will be recording for the section. And I must commend every one of you, every participant who have taken your time to be part of the program. I'm sure you've gotten value for your time. Impressive attendance. And thank you so much, everyone. Thank you for always being part of our programs. We have quite an amazing lineup of ALPs for this board here. Quite amazing events. So always do well to follow us on our social media and get first-hand information on our ALPs. I think this is one of the brilliant ALPs we've had, and we have so many to come. Thank you so much. Thank you. And I think I will leave it here. That's the lectures, the learning we've gotten from here, we'll take them off and also improve on them. And I hope that these lessons, it's just a starting point for us in our career. Yeah, so thank you very much, and back to you, Chizoba.
All right, thank you so much for this graceful vote of thanks and wonderful closing remark. In conjunction to what Mr. Locke has said, I would like to especially thank the host, each and every host here today, for making our time and for being actively involved in for being actively involved in your efforts, your dedication, and your due diligence. Very appreciated. And I would not like to be biased in my appreciations and commendations. I would like to thank every guest here who has taken time to come to join this part and bask in the well of knowledge. Our very own speaker, I want to thank you all for being involved. We truly appreciate you, and we promise to give you the best and the best what's called the best lectures, the best meetings, best events moving forward. And I want to wish you all a good night. And once again, thank you for being present. You have a lovely night. Thank you.
Right. Good night, everyone. Good night, Paul. Paul, good evening. Can you hear me?
Yeah, good evening, good night.
Good night. My predecessor is on the call. I want to give a special shout out to him. He joined. He was the former ALP lead and is currently the career and technical lead. He's having a session on Saturday, so please join in. Thank you, everyone. My YP chair, Mr. Lucky, thank you. Thank you to all the students, collaborators. Thank you to our moderator. Thank you very much. Thank you, Kachi, for that exciting Slido quiz. It's always a pleasure with you. Thank you to my speaker, my esteemed speaker, William Okon. Thank you. You just reminded me of the things that I do at work. It was such a pleasure hearing you. You're talking about the GC and everything. Thank you so much. All right. Thank you to all the collaborators now, BUK, Uniport. Thank you. Thank you so much. From me to you, good night. See you next week. Next week, Saturday, we have another ALP by 5 p.m. Please come out in mass, and we'll be collaborating with a school from Uganda, Makere University. Please come out in numbers. It's going to be another exciting ALP. Thank you very much. Good night.
Good night.
Good night, everyone.
Good night. Say hi to your friends. Bye.